Okay. So in radiation, there are a lot of topics. One is photoelectric effect, X-ray production, then this alpha, beta emissions, and those things. So first of all, let's see photoelectric effect. Okay. Photoelectric. So what does this photoelectric effect say is, normally, earlier days they told like light has only wave property like that. Okay. But after doing this experiment and everything, they couldn't explain with the wave property. Then only they told like light has some particle property and it is coming like energy packets like that. And they started to talk about photons. Okay. So what is happening in the photoelectric effect is, see in the heading, photoelectric effect. That means for a surface, a photon. Okay. When a photon in the surface, electron will get ejected. So what is happening here is, now every surface, when you consider, it is made up of atoms, right? A lot of atoms get together, the surface is made. Now what is really happening inside this photoelectric effect is, like say an atom, okay? This is the nucleus, this is the sub-energy levels. So electrons are revolving like this. Okay. So what is happening here is, photons are coming. So when a photon comes in, it is electron like this. What does this photon try to do is, it try to remove this electron. Okay. Now you see, this is nucleus. This electron, there is an attractive force now between the nucleus and the electron. In order to remove this electron from this nucleus, the photon must supply some energy. Otherwise, more than this attractive force, if it can give energy, it can remove. But there's a special property of this photon. But that is the key point. Is one photon can give its energy to only one electron, and it will be completely destroyed. So the thing is this. Now let's say, in order to remove the electron from the valence chain, let's say we need like 4 electron volt energy we need. Okay. So you know electron volt. Electron volt is 1 electron volt is equivalent to 1.6 into 10 to the power minus 19 joules. Electron volt is one of the unit of measuring energy. Since these energies are really small, we are using electron volt. Sometimes we talk in joules also. So in order to remove this electron from the valence chain, there is an attractive force to overcome and remove. We need 4 electron. Now this photon is coming. No, every photon has different energies. So let's say that this is a metal surface, so different photons are coming. Okay. So if this photon, let's say it has 4 electron, it is carrying a 4 electron volt energy. It can remove this electron. But let's say if a photon comes like 3 electron volt or 2 electron volt, less energy than this card. See, the photon energy is 2 electron volt. Now, in order to remove this electron, minimum 4 electron volt energy we need, but not enough. In that case, the photon won't remove this electron. It will go back. Okay. If a photon removes an electron, what happens is, it will give all of its energy to its electron and it will get completely destroyed. Okay. So that is some key points you should remember. One photon can give its energy to only one electron. If it can remove, now let's say 2 electron volt energy photon is coming. Now in order to remove this valence electron, we need 4 electron volt energy. That means can't remove in this case. So the photon, what happens is, it will try to remove this, but can't, because there is an attraction with the nucleus. So in order to remove, you should overcome this attraction and remove. Therefore, this photon will come. It will try to remove this electron, but can't. Therefore, that photon will go like this. Okay. So instead of 2 electron volt, if let's say 4 electron volt, what photon is coming, then it can remove. No, finally it will remove the electron. Right? If high energy electrons come, energy photons come, like let's say 5 electron volt, 6 electron volt, then it will definitely remove. Why? In order to remove this electron, 4 electron volt energy is enough. But if the photon carries a higher energy than that, 5 electron volts, 6 electron volts. Therefore, definitely what we can say, definitely we can remove this. Okay. So now this is what happening really. Now a surface means any surface, metal surfaces. This is one atom I told. There are lot of atoms like this. Okay, lot of atoms. The surface is made. Okay. Now what happens is we are ejecting photons to the surface. Okay. Lot of photons are coming to the surface like this. And what happens means if the energies, different energies, let's say 5 electron volt, 6 electron volt, 8 electron volt, 3 electron volt. So and it is hitting this electron, some may remove, some can't remove. That means if this similar to this, there are so many atoms here. So if it is 4 electron volt, needed to remove this 5 electron volts, it can remove. If there are 3 comes, it can't. So all the photons, okay, which is hitting the metal surface, if they say it will remove electrons, no. Okay, in order to remove it, it should be more than this energy. So this 4 electron volt is the minimum energy we need to remove the electron. That one we call as phi. We use the symbol phi. That is work function. Okay, so minimum energy in order to remove this one 4 electron volt. Now photon is carrying energy. You know, photon energy, there is an expression E is equal to H. So where H is the Planck constant and F is the frequency. Okay. Now let's say the 5 electron volt energy photon is coming. Now in order to remove this electron, 4 electron volt energy is enough. But what I told is, if a photon removes an electron, it will give all of its energy to the electron and it will be completely destroyed. Then it has 5 electron. Okay. Then in order to remove this electron, 4 electron volt energy is enough. But if it removes the electron, it will be completely destroyed now. Their energy can't be destroyed or energy can't be created. Energy will be always transferred. Okay? What happens to that remaining 1 electron volt energy? What is going to happen to that remaining 1 electron volt energy means that will be converted as kinetic energy of this electron. Okay, so what is happening is this photon is giving 5 electron volt energy. So 4 electron volt is enough in order to remove this electron. The additional 1 electron volt is the kinetic energy which will be stored. Therefore, now we can write down the photoelectric effect equation. The 5 electron volt is the photon's energy, which is H. That is equivalent to 4 is the work function phi plus 1 is the kinetic energy, maximum kinetic energy which the electron can get. Therefore, HF is equivalent to phi plus kinetic energy maximum. This is what happening here. Did you get it? Hello?
Miss, how do we calculate work function?
What? Hello?
How do we calculate work function?
Work function you can't calculate. It depends on for different metals it will differ. They will give. Now sometimes if they give like HF and kinetic energy maximum, you can find work function, but mostly they give in the questions. Are you okay with this equation?
Yes, miss.
Okay. So do you want to do sums in this equation? Okay. Shall I move to the next?
Shall we do one question, miss?
Okay. Then quickly write a simple note like that. So in this diagram or something in the rough side. And I'll read the question and try.
Okay, miss, done.
Okay, and before doing a question, I want to tell something also. And this equation, there are some other formats also we can write. Okay, now the photoelectric effect equation is HF is equal to 5 plus kinetic energy maximum. Now sometimes when they are giving questions, okay, Without giving frequency, they are giving wavelength. Okay. In sound, you study the equation. V is equal to f lambda. Sometimes you will use V is equal to f lambda or C is equal to f lambda. Okay. So instead of this frequency, we can write C over lambda. Then I can rewrite this equation. Xp over lambda is equal to pi plus kinetic energy maximum. This is another format of this equation. Okay, so if it depends on the data. In some questions, they will give they may give wavelength and kinetic energy maximum, and they can ask to calculate phi. Okay. Now what I told here is HF is equal to pi plus kinetic energy maximum. I told like if 5 electron volt photon comes, 4 electron volt is the work function needed to remove this, and 1 electron volt kinetic energy is enough. Sometimes if they give like 4 electron volt is energy photon is coming, that means 4 electron volt is needed to necessary to remove that. In those cases, no kinetic energy. So sometimes if kinetic energy is 0, we can write this equation as HF is equivalent to pi. Okay? If kinetic energy is 0, HF is equivalent to pi, we can reduce it. Or else we can write HC over lambda is equivalent to pi. Okay. And this is a special case. Okay? When kinetic energy maximum is 0, that means in order to remove this electron, in order to remove this electron, 4 electron volt energy is enough. So what we are supplying a 4 electron volt, photon is coming and ejecting. Okay, that means kinetic energy maximum is 0. Now we are going to learn a new term, threshold frequency and threshold wavelength. Okay, this is the normal photoelectric equation. HF is equal to pi plus kinetic energy maximum is the equation. That is in which case it is applicable. That means you want to remove this electron, 4 electron volt energy is enough. The photon energy is more than that. That means 5 electron volt photon is coming. Whereas 6 electron volts photon is coming. That means 6 electron volt photon comes, 4 electron volt is enough. So 2 electron volts will be stored as kinetic energy. The reason, but remember, one photon can give its energy to only one electron if it is going to give. Otherwise, it will go. Then that photon will be destroyed. Okay, now the case what I'm talking here now, I'm going to talk is a 4 electron volt energy is enough in order to remove this electron. So 4 electron volt photon is coming. So what does it happens means if we remove this electron, then electron won't have kinetic energy, it won't go. Okay, so in that case, kinetic energy maximum is 0. We can reduce this equation. This HF is equal to pi, H0 lambda is equal to pi. In that case, we are using a special term for this. This we call as F naught threshold frequency. Threshold frequency. Okay. So what is this threshold frequency? It is the minimum frequency. Okay. Now, in order to remove this electron, the minimum frequency is threshold frequency. See, now this is 4 electron volt of this energy. So, in order to remove this electron is in the 4 electron volt energy level. In order to remove that 4 electron volt photon, we are supplying. So, we can give more than that. Definitely, if I give 5 electron volt, 6 electron volt, this electron will be removed, right? And kinetic energy maximum will come. So, minimum, in order to remove it, then minimum energy what we need is 4 electron volt. That HF is photon energy. In that case, F naught is the minimum frequency. That minimum frequency we give a term as threshold frequency. Okay. Then this is lambda naught. What is lambda naught is threshold wavelength. Okay. But frequency is minimum, threshold wavelength is the maximum. Why is that? We know, C is equal to F lambda. Frequency is equal to C over lambda. Now, frequency is minimum means, frequency is minimum. Really low means, if I increase the denominator, lambda increases, F decreases. That means F naught we call as the threshold frequency. That is the minimum frequency, the photon which it should hit in order to remove this electron. Lambda naught we call as the threshold wavelength. That is the maximum wavelength. Okay, that is the maximum wavelength. Other way around. Frequency and lambda other way around. Okay, so normally we don't that much talk about threshold wavelength. So, but threshold frequency is important. That is the minimum frequency in order to remove that. Beyond that, frequency, if it comes, definitely it will remove. And another important case you should consider is photon where hits the electron. Now we can't eject the photon, go and hit this electron like that. We will keep a photon beam like this and it will come like this. Sometimes the photon will come and hit a position like this. There is no electron, no. Therefore, it will go in this way. That's why all the photons, okay, all the photons hitting this metal surface won't remove the electrons. It should hit in the correct position. That's why during experiments and those things, they say if we eject like if 1,000 photons hit the metal surface, nearly only 200 to 250 electrons are being emitted. Because there are so many factors affecting this. It should hit the correct position. Sometimes, let's say another photon is coming and hitting this position. In order to remove this 4 electron volt we that comes as 3 electron volt. We can't remove it, then it will go like this. So that's why the position and everything determines. So normally, according to experiments, what they say is if 1,000 photons like hit a metal surface, nearly 200, like 20% amount of electrons only being removed. You get it?
Yes, miss.
Okay, note down that threshold frequency and threshold wavelength. We'll do the question. That part also really important. This equation, this equation, this equation, this equation, this equation.
Miss, done.
Okay. Then write down this equation, question. Cesium has a work function of 1.9 electron volts. Cesium has a work function of 1.9 electron volt. Find its threshold wavelength. Cesium has a work function of 1.9 electron volt. Find its threshold wavelength. Then choose the correct equation, substitute and find it. You know the values, right? H value is 6.6 into 10 to the power minus 34 joules second. That they will give in the paper. H is equal to 6.6 into 10 to the power minus 34 joules second. C value is 3 into 10 to the power 8 ms minus 1. H value is 6.6 into 10 to the power minus 34 joules second. C value is 3 into 10 to the power 8 ms minus 1. And this value, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. So give the answer in SI units. Huh? So lambda should be come in meter or nanometer like that. If it is meter, also good. Sometimes they will specifically ask to give in SI units. Otherwise, if you give it in other units also, they will give marks. They specifically ask when to give it in SI units.
Miss, I got 1.04 into 10 to the power minus 25.
1.04 into 10 to the power minus 25. Wait, what is the equation did you use? HF over lambda naught is equal to pi? Equation?
HC over lambda equal to pi.
Yeah, that is correct. Then you substituted for C, 3 into 10 to the power 8, H 6.6 into 10 to the power minus 34. 5 you substituted 1.9 into 1.6 into 10 to the power minus 19. Okay, I'll write and show.
Okay.
ask this question means now they ask threshold wavelength. So first write down this expression. Phi is equivalent to hc over lambda. Then lambda is equivalent to hc over pi. So h is equivalent to 6.6 into 10 to the power minus 32. Then c is 3 into 10 to the power 8. Divided by phi is 1.9 electron volt. So 1 electron volt is this much into 1.6 into 10 to the power minus 90. Substitution correct?
I forgot to convert into electron volt.
This is 1.9 electron volt now. 1.9 electron volt I am converting into joule. The thing is C is measured in this is what happening. Okay, here. Now phi is equal to hc over lambda, lambda is equal to hc over pi. Now unit of h is what? hc over pi. Now a unit of h is joule second. Now this c is ms minus 1. Now lambda I should get it in meters. SI units. That's why now this is in electron volt. Now I gave is 1.9 electron volt. Here they will give in the paper. If they give some other units other than joule, they will give in the paper that electron volt is how much. So 1 electron volt is this much. 1.6 into 10 to the power minus 90. But our work function is what? 1.9 electron volt. So if 1 electron volt is this much, then 1.9 is how much? Then 1.9 into this. Then I am converting into joule. Then only I will get lambda in meter. If you didn't convert it to joule, you will get the value for lambda, but it will be some other units, electron volt minus 1 like that. It won't be in SI units. Okay? Okay. After writing, tell me.
Done, miss.
Okay. Then we can draw a more graph for this. Did you do graphs? Photoelectric effect?
No, miss.
The small graph sometimes they can ask on one graph. This same equation, now HF is equivalent to 5 plus kinetic energy maximum. Okay. So in case if they ask like that small graphs means y is equal to mx, y is equal to mx plus c like that to draw. So sometimes they can ask draw the graph for kinetic, if they ask like kinetic energy maximum versus HF. If they ask to draw a graph for this. Okay, kinetic energy maximum versus frequency, let's say. So always now this when you are doing a graph in physics, and this is what they ask is y-axis is kinetic energy maximum, x-axis is frequency. First of all, then make it subject. Then what we can take kinetic energy maximum in the y-axis, that is equal to pi. We can take it to other side. So hf minus pi. So this is in the form what y is equal to mx minus c. So that means you will get a graph like this. Okay, so the gradient of this graph will give Planck constant h. Okay, gradient will give h. So the intercept of this graph, it will give pi. This is the work function. Okay, sometimes they can ask a question like this. What they can ask means they can give a graph for you. Okay, kinetic energy maximum versus frequency. They could have drawn a graph like this. Let's say they are giving a graph like this in exam. They are asking. This is the kinetic energy maximum versus frequency graph. Okay. And they gave a graph like this. And they will give some values. 1, 2, 3. And they will give here 1, 2, 3 like that values. And they will ask what is the work function of this material. If they ask a question like that. Now, how to find the data using graph? Now, normal equation, you know. HF is equal to pi plus kinetic energy maximum. If they give frequency and kinetic energy maximum, you know to calculate pi. Sometimes if they ask threshold wavelength, threshold frequency, you know the equation reduces. Sometimes now rather than going through equation, they can ask a question in this way also. What is the way? They can but HF is equal to pi plus kinetic energy maximum, they can give a graph. Now, what is this graph? Is kinetic energy maximum versus frequency. So, if they give a graph, like any question in physics, if they give a graph, then you know the equation of HF is equal to pi plus kinetic energy maximum. Now, see the graph. Y-axis they have chosen as kinetic energy maximum. They gave the graph, okay? X-axis they gave frequency. Then you make that its subject in the way y is equal to mx plus c, or y is equal to mx minus c, or y is equal to mx. Therefore, here see kinetic energy maximum is the y-axis. I am taking to this side. HM minus 5. That means y is equal to mx minus c. So according to according to this graph, see, like mh is there. Therefore, gradient of this graph gives Planck's. Sometimes they ask the gradient of the graph depicts what? Planck's. Okay. So then phi. What does phi is a work function. Now, if they give a graph like this and ask you to find phi, what you are doing is to take your pencil. Okay. The example, you have to stretch this. And where it intersects, that will be the phi value. Sometimes they can ask. Or else sometimes they can give any 2 points. Okay, gradient, this point they can give 64, 32, some points like this. Okay, and they may ask you to calculate Planck constant. That means you know to calculate the gradient. Of gradient is difference in y coordinates. Difference in y coordinates divided by x coordinates, and you will calculate the gradient. And using the gradient, you can write h. But sometimes most of the people, what they make a mistake is when calculating the gradient, you must be careful. The thing is, they will give powers like this, okay? Frequency into 10 to the power 14 like that. Okay, kinetic energy maximum into 10 to the power 6 or like that, they will give powers. Most of the graph question, it is coming 10 to the power 14, 10 to the power 6. Thing is, the frequency and everything is 2 into 10 to the power 14 hertz, okay? 1 into 10 to the power 14 hertz. So if they ask question like 1 into 10 to the power 14, 2 into 10 to the power, they can't draw in the graph. Therefore, graph, it is easy to mark 1, 2, 3, you know. It is difficult, right, to put 3 into 10 to the power 14 like this. Therefore, what they are doing is they are putting the numbers and putting the power here. So in that case, when you are writing the equation for the gradient, okay? So when you are writing the equation for the gradient, if they ask to calculate the gradient of this graph, that means h Planck constant they are asking, not this equation. Physics, so many graphs are coming now. Some graph they are asking. So in order to calculate the gradient when you are writing these points, now let's say 32 into 32 minus 22, your y coordinate difference. Okay, 32 minus 22, you should put this power. Don't forget that. 10 to the power 6 into 10 to the power 6 divided by, when you're writing others, 64 minus 32. Okay, 64 minus 32 into 10 to the power 14. Many people forget to put this power. Okay, if you put this power wrong, answer will get wrong. And if they ask a graph question in radiation, definitely it will come in power. Now see, the h is what, when you calculate the gradient, you should get h. H value is 6.6 into 10 to the power minus 34 like that. So definitely it will come in power. So sometimes when you calculate, if you forget this power, you will get a 6.6 value, but the power won't come. Okay, therefore, then when they give a graph and ask question in photoelectric effect, be careful. This is the famous graph they can ask. Kinetic energy maximum is equal to HM minus y. So they can ask step by step, they can ask. First question, what they can ask, write down the photoelectric equation. HF is equal to y plus kinetic energy maximum, you get that. Then they can ask you to write threshold within threshold frequency, write down the equation. Then they can give a small calculation. Then they can give the graph like this, they will give a graph. They will plot and give the graph. Then they can ask, find the gradient of this graph. So what does the gradient give? Then you should write Planck constant. So when calculating the gradient, sometimes they will give two points and they will give the coordinates also. And this is 64 and they will give the coordinates, then you can directly put and find the gradient. Sometimes they won't give the coordinates, you should find here using the ruler, this point intersects and this is where. Okay? But they will circle and give the points, a lot of points like this. But when finding the gradient, be careful, don't take near points. Now, when you are calculating the gradient and all for a graph, now they give a graph like this, let's say photoelectric effect. Now, when you are calculating the gradient, don't take like near points like that. Take any two, like a broad range. Then the answer won't be wrong. Okay, so you have to calculate the gradient. Don't forget these powers. 10 to the power 14, 10 to the power 6. Then intercept means you can extend this, and where it cuts the y-axis, that will give the intercept. So that is fine. So this, like this, they can ask a question in photoelectric. Did you get it? Graph style. Hello. Can't hear you now. Hello.
2. Can you hear me, miss?
Yes.
Miss, can you hear me?
Yes,
So
I
they
can
have
hear you.
asked
Did you
about,
get the graph?
yeah.
Okay, note down that. Careful when calculating the gradient and all these powers. Most of the time, most of our students make mistake those powers and everything. Okay, take a small note like that, graphs, and tell me. Let's move to the next one.
Okay. Okay, miss, done. Miss, done.
Okay. Any doubts in graph?
No, miss, clear.
Okay. Next, put the heading X-rays.
Miss, there's a thing called photons have momentum.
Yeah, photons have momentum and de Broglie thing. Shall I do that next then? Okay.
Okay.
You are asking a question. What did you ask? You want to prove that
In
momentum
the
is
book, there is called photons have momentum. Can you do that?
yes. Photons have momentum, and they are talking about the wave particle duality and de Broglie, right?
Yeah.
Yeah. Okay. So let's look at that next. Okay, that's what I started with. Now the thing is this photoelectric effect. Normally earlier days what they told is light has only wave property. They told light doesn't have particle property. Then after this photoelectric effect and experiment and everything, it was like difficult using the wave property how this is happened. Then after that only after doing experiments and all, this Einstein discover this photoelectric effect equation that light has particle property too. If light doesn't have particle property, we can't explain what photoelectric effect. Therefore, after that only, after so many, now the science is like that. No one will tell one theory and everything. After the scientists coming, they try to develop more and more and find more information. Now, what this topic comes under is wave particle duality. Okay, so it has wave property as well as particle property. Okay, so this photon, it has momentum. So who talked about this first is de Broglie. So there is an equation. De Broglie wavelength we say lambda is equal to h over p, where h is the Planck constant and p we call as the momentum of the photon. Okay, so what they're telling is to explain this photoelectric effect of light, we have to introduce a particle property to light. That's why they are talking about momentum. Okay, it has a velocity, it is moving, particle nature. That's why photon has a momentum. So we can calculate the momentum using the equation lambda is equal to h over p. This is the equation we are using to calculate the momentum of the photon. So if we ask momentum, we can write p is equal to h over lambda. Yeah, lambda will be the particular wavelength. What I told is different photons are coming and hit the surface. 5 electron volt energy, 4 electron volt, 3 electron volt. So this is photon energy. We can write E is equal to H. So H we can write H is equal to C over lambda. Right? C is equal to F into lambda. So if I know the energy, I know Planck constant, I know this speed of light in here. Therefore, I can calculate by lambda. So each photon which is being emitted, it has different wavelengths. Now, according to its wavelength, it will have different momentums. Therefore, we can determine the momentum of a photon. So, who told about this is de Broglie. Okay, de Broglie only proposed that any particle, its momentum, it can be written as this. What I am telling is, you must be clear. The light has particle property that was discovered by Einstein. In photoelectric effect equation, HF is equal to 5 plus kinetic energy maximum. He said light has this what particle property? This particle's momentum, how it is moving and velocity, its travel. This one suggested by de Broglie. Therefore, we are keeping a special name to this. This lambda we call as what? De Broglie wavelength. Okay?
Okay, Miss.
Okay, note down this. So here in the note also they are telling de Broglie proposed that any particle of momentum p has an associate wavelength lambda given by lambda is equal to h over p, that is equal to h over mb. Where lambda is called the de Broglie wavelength.
Okay, Miss. Done.
Okay. What else? You have doubts in photoelectric effect? Should I start X-rays? Any other doubts in photoelectric effect? Yes?
No.
No. Okay, right? Yeah. Because photoelectric effect is easy, not that much concept. So X-rays first, let's see how X-rays are produced. Okay? And it's FPL.
Okay.
Okay. Then put the heading X-rays. So X-rays, the concept is a little bit different. Now, photoelectric effect, it is the opposite process of photoelectric effect like that. Now, in photoelectric effect, what happened? Photoelectric effect, now the photons come and hit the metal surface and electrons got ejected up. X-ray, other way around. We are going to send electrons and hit a metal target and photons is going to be emitted, X-ray photon. It is the opposite effect of photoelectric effect. What I am telling is photoelectric effect, what is happening is, now this is a metal surface, any metal, cesium or sodium or like that. So what is happening is this photon is coming and hitting the metal surface. This one we learn in photoelectric effect. So many atoms are there in metal. So it is removing an electron and electron is being ejected from the metal surface. That we call photo. It is in the name. See, photoelectric effect. Photons come and hit the surface and electrons get emitted. That is photoelectric. X-rays is other way. Electrons are going to come and hit the metal surface and X-ray photon is going to be emitted. So let's see how we are doing that experiment with, let's say, so X-ray tube. So first let's do it. I'll draw the X-ray tube. So this is a battery like that.